Hi there, everyone. Welcome to the very first day of the Kaggle Generative AI Intensive course, a 5-day course being delivered virtually so that you can learn everything there is to know about generative AI and how to use it in your AI applications. Today, we have a bunch of really great guest speakers that are going to be talking all about foundational models as well as prompt engineering. And even though we had a couple of snags on the live stream earlier this morning, we've packaged up to the video all together such that you'll be able to have a really, really nice experience walking through both an overview of the course, a Q&A, a brief overview of some of our code labs, and then also finally our pop quiz towards the end of this series. So this 5-day course on generative AI with Google by Kaggle will give you daily assignments in the form of white papers and podcasts that you'll be asked to listen to. These assets explain the what and how of how all of the generative AI models, tools like vector databases, agents, how all of these different techniques and tools work together. And the accompanying Colab notebooks are intended to show you how to use it, both our generative AI APIs as well as other assets like open source tools that you might use with them. We've also got a great Discord channel for you to discuss and to kind of brainstorm ideas. And to also get the direct ability to engage in Q&A with our guest speakers. We're hoping that you'll take this moment to kind of deep dive into all of the content that we've created and to learn some of the fundamental, important, and kind of top-of-mind concepts around tech with generative models. So as I mentioned, this is a 5-day program over the course of November 11th through November 15th. Today is our very first day. And it will be discussing all about foundational models and prompt engineering. So with that, and without further ado, let's get started with our Q&A for this very first day. Greetings and welcome, everyone. We're excited to have you today for our first day in our Generative AI Intensive course sponsored by Kaggle and the Gemini team. We have a lot to cover today, so I'm going to get right into it. Everything from answering the great questions that you've been asking on Discord to having some exciting guest speakers kind of talk about what they've been working on, also walking through some collabs and some demos, and then finally a pop quiz. So really excited to have you here today. We've been really energized by the great questions that you've been adding on Discord, and I'm excited to see just how much everyone is caring about learning more about large language models, multimodal models, and generative AI at large. My name is Paige. I'll be your host for this week, and I am joined by many of my colleagues here today. And hopefully we'll be doing some introductions a little bit later. So this 5-day generative AI intensive course has a combination of daily assignments, the Discord threads that we've been discussing, as well as these live Q&A sessions. We'll have them 5 days a week from November 11th to November 15th. And it covers everything from foundational models and prompt engineering to embeddings and vector databases, AI agents, domain-specific models, and even ML ops for how you can maintain these model systems over time. Today is all about foundational models and prompt engineering. And so we have many folks on the call who have been doing this as their day job for the past many years, and who are kind of experts to help answer your questions as you cover all of the great readings and the chat threads and the discussions each day. So with that, I am going to get into it in the interest of time to make sure that we have ample space to discuss all of your questions. This Q&A segment will be a continuation of all of the things that you've been seeing on Discord. And I want to make sure to thank our wonderful generative AI discourse moderators, Polong, Kaz, Mark, Eric, Erwin, Miles, and many of the other folks that have been kind of diving in and helping. Make sure to emoji thank them, and also text thank them. I know that they've been busy and working in every single time zone. The sun never sleeps on generative AI at Google. So with that, day number one, our expert host panel includes Logan Kilpatrick, who's the product lead for AI Studio, Lee Boonstra, Alexi Severin, Majid Amin Baraktan, Daniel Mankiewicz, Chuck, and Anant. And I'm excited to have everyone here today. As an example, we have folks that have worked on reinforcement learning with human feedback, people who have been working on the Gemini app model inference, making it performant and efficient, technical directors from the office of our CTO, and even more. And with that, I'm going to go ahead and start with our first question to Logan. Good to see you, Logan. How are you doing?
I'm doing awesome. I'm excited to both hear the questions from folks, but also hear some of the questions for some of the other panelists.
Excellent. Very cool. And the ML developer team has been shipping so much just recently. It feels like every day I log on to LinkedIn or to Twitter or X or whatever it's called now. It seems like there have been new product releases. Tell me which features you're most excited about and which have already launched or about to launch.
Yeah, that's a great question. I think the two that are top of mind right now, about 2 weeks ago, we landed grounding with Google search, which is really exciting. So I think this will surely be a topic of conversation over the next 5 days, but LLMs and hallucination and grounding and RAG, grounding with Google search is a way to sort of tap into the search index that Google has and bring some of that information to ground answers, or rather ground questions that users of LLMs have. So super interesting. If you just Google search grounding with Google, you'll find some of the links across the developer side, the enterprise side. So excited about that. Happy to talk more about it. The other thing is Friday we landed OpenAI compatibility, which I'm super excited. So for developers who are already using the OpenAI SDKs and libraries, you can now try out the Gemini models using those SDKs and libraries by only changing like 3 lines of code or something like that. So excited to sort of reduce the friction for developers who are excited about using Gemini. And hopefully we'll hear a bunch of great feedback about that launch as well.
Excellent. I personally have been really jazzed for the OpenAI API compatibility. It's been really straightforward to convert notebooks that might have been preferring the OpenAI APIs to just using Gemini, and to be able to compare and contrast between the two. So those are definitely 2 exciting things that have come out. And I encourage everyone to take a look at the OpenAI compatibility and then also the search grounding features within AI Studio. I think it's especially cool that you can use search grounding with even some of our smaller models like Gemini 1.5 Flash and Gemini 1.5 Flash 8B. I've been loving both of those for my projects, especially things requiring code execution or super fast inference. Tell me a little bit about those 2 Flash series of models and how you can do so much so quickly with a very small cost footprint.
Yeah, so we landed after a bunch of work internally, we landed the Flash AP model, which is the smallest sort of Gemini hosted model that exists, 8 billion parameter model, and really pushes sort of the envelope of, compute intelligence per dollar. I think we've seen a bunch of those tweets, Paige. You and I have been ones putting those out, but it's like 2-3 cents per million tokens. If you're using cash tokens, it's 1 cent per million tokens. So just like an absolute crazy amount of intelligence that you can get for a couple of cents. And I think the sort of interesting thread of why those small models are interesting to me is because a lot of the frontier use cases of AI are actually bounded by cost and token cost. So like there's a lot of things like the developers actually inherently have a disincentive to build, because it's like you are paying the more AI the more AI you build into something, the more you pay. And I think Flash AP is like a great example of sort of pushing the frontier of trying to like remove that barrier so that developers can actually just build the things that they're excited about, and not need to sort of worry about, the incremental amount of cost that they take on.
Yeah. Amazing. And then one last question, and then we're gonna bring in some more folks to discuss, especially the production applications of generative AI. DeepMind's multimodal models, I'm thinking particularly of Imagine and VO for video generation, Lyria for music generation. They unlock some really interesting new applications, especially when coupled with the Gemini models. What has been your favorite application for these kind of multimodal output scenarios? And how do you think about coupling those with the Gemini APIs?
Yeah, that's a really good question. I think it is so hard to create, or rather, I think text as sort of like an output mechanism for models. I think developers have found the interesting things to do with text. Like, you build chat apps, you sort of process data, you do a bunch of stuff. It does feel like we're actually still pretty early in this, like, what are the real actual production use cases of multimodal output creation, both in image, video, and others. Like, I feel like we just haven't, there hasn't been as much ubiquitous access to those models, and thus developers haven't had enough time to really build interesting things. I think the thing that I'm personally excited about is actually comparing, or rather bringing text to life using those things. I think there's just a lot of text in the world, and humans in a lot of cases are inherently visual. And I think if it's possible, and we sort of saw this with Notebook LM actually as an example, if you can take a bunch of written content and bring it to life in audio form, it actually makes the experience 10x better in some contexts. And I can imagine, the sort of I'm not on the Notebook LM team, so this isn't actually a product vision for them, but you bring to life sort of the huge corpus of text documents you have in the form of a video instead of just an audio conversation. I think that's a crazy future world to live in, and I think it is going to be models like Imagine and VO that actually enable that mission to come to fruition. So it's going to be exciting. And I see your lights just turned off. This is folks who don't know the Google offices. The lights turn off all the time, so it's a normal occurrence.
Yes, and I love that use case as well about how you can sort of bring life to text documents, or even to things like GitHub code bases through video, through audio, through images. I think my favorite use case so far has been doing book trailers. So taking in a PDF book, automatically, segmenting it into different prompts. And then creating a short video to describe the book. I love it, and would love to see more of that vein. So thank you so much. This has been wonderful. I am going to pull up our next question, which is all about reinforcement learning with human feedback. And I'm going to bring on stage Alexi. Alexi, you're correct me if I'm wrong. You're our lead for RLHF for the Gemini app. Is that correct?
Correct.
Excellent, thank you. And I'm really curious to learn more about how the Gemini app is using RLHF to help improve its responses. How does that process work? How do you sort of use user feedback to improve the models over time, or to improve your app experiences over time?
Yeah, so I mean, it's a very big topic, so maybe it makes sense to say a few words on a high level how the LLMs are fine-tuned. So the de facto recipe today for post-training state-of-the-art LLMs is to do it in 2 steps, SFT and RLHF. SFT is supervised fine-tuning, where we use demonstration data. And I mean, typically to get good results, this data needs to be of extremely high quality, and it's most often produced by human experts, so it's quite expensive to get. RLHF is a powerful technique for aligning models to human preferences. Yeah, think of making responses safer, more helpful, or factually correct. And it's a bit more complicated than SFT, but in brief, we use a collection of input prompts to generate responses from the model that we're trying to fine-tune. and then use another model called reward model to penalize responses that are bad and reward the good ones. And this reward model can be fine-tuned on different types of preference data. So typically it's human preference data. This is what RLHF stands for, like human reinforcement learning with human feedback. And this data can be collected from human expert raters, just like SFT data, or it can also come from user feedback. So people, like users interacting with Gemini chatbot on the desktop or their mobiles.
So the thumbs up, thumbs down interactions that we do with the models actually lead to better performance over time. Is that what you're saying?
Yeah, it helps us to produce models that are perceived as more helpful to our users. So this is kind of one of the primary mechanisms to align our models to human preferences.
Amazing. Exactly. That's really exciting to hear. And I know folks have been learning all about RLHF and all about improving models with things like human feedback through the course of their readings. The next question is from one of our folks at Google. So I've been wondering, since large language models learn from massive sources of data, do large language models simply interpolate within their training data, or can they go beyond to make new discoveries? And Amin, how about you answer that? I think, and then also welcome back. I believe you used to work at Google DeepMind, and now you've started your own company. Is that correct?
No, actually, I used to work at DeepMind, but now I'm work for a new company called Quadrature. So yeah, I switched industry actually.
Cool. And Quadrature, is that in the finance industry and quantitative research?
Yeah, quantitative research. These days, you can basically apply AI in any application, and finance has been also very, very interesting application.
Very, very cool. So tell me about the models making new discoveries. Have you found that is the case, or are they just next token predictors?
Yeah, I mean that's a like a philosophical and interesting question, but I believe the answer to this question is yes. The models can definitely go beyond their training data, and the technique that will let them do that is a well-known search, basically. So the first example that we saw that was the work called Fun Search that we did in DeepMind end of like 23. And in Fun Search, we basically used an LLM to search in the space of Python programming language for, let's say, a very hard problem, like an NP hard problem. And the way it worked was that we basically paired a large language model with an efficient, let's say, evaluator that would provide feedback on how good each solution is. And then with an iterative algorithm, it managed to discover new solutions for some open problems in computer science and mathematics. So the core idea was that the LLM would basically propose, let's say, solutions like a piece of code for a particular problem, and then the evaluator would give some scores on how good that solution is. And then there was an evolutionary algorithm that would select the best solutions that the LLM discovered so far. It would present it to the LLM, and it would basically ask it to make it better. So in some ways, it was doing best shot prompting, like an automatic way of prompting the LLM. We would just show it good solutions. We ask them to make better. The LLM comes up with something new. We would show it again and ask it to make it better. And this sort of process is repeated about 100,000 of times. And then the code that it starts with is something like a return 0, and it would like evolve into something very interesting and complicated that would actually result in some new, let's say, solutions for open problems. And because these basically solutions as never discovered by humans before, it kind of shows that the LLM discovered something new that wasn't in its training data. And this concept has been basically studied a lot, like in the history of AI, and recent examples. Recently, it has become very popular in the modern LLMs, and it's referred to by, for example, test time compute or inference scaling and other terminologies. And the way it works is that you can basically when you ask a question for the LLM, you allow the LLM to think, and the LLM would basically generate multiple scenarios and generates like chains of reasonings. And then it has a mechanism to understand that, okay, which one is more likely? And then it would just iteratively repeat this process. And by simulating different possibilities, it basically search at inference time. And by searching at inference, it can manage to basically discover something new because it can bootstrap its own knowledge.
Very cool. And that makes me think that we've only just begun to tap into the kinds of things that large language models will be able to accomplish or to achieve.
Exactly.
I'm really, really excited to see what the next couple of years hold.
Exactly. I think Rich Sutton puts it the best way. We have in the Bitter lesson that we have two techniques that basically scale infinitely. The first one is learning, which sort of we cracked by large amount of data and just with the first, let's say, generations of models we saw. And then the next technique is search. And I think we are at the moment where people are starting to scale search and throwing compute at inference time. And that's going to unlock a whole lot of new capabilities, especially for reasoning capabilities. And that's going to be very exciting.
Excellent. Thank you so much. I think this also leads is a great lead to our next question, which was from our Discord app. And I think this is for Majid. Majid, you're our inference lead for the Gemini app. Yeah. Excellent. And so this question is really all about can larger language models be used to train smaller ones? Can we take some of this knowledge that might have been obtained from a larger model and use it to improve smaller models? Things that kind of like the models that we embed within many of the product surfaces at Google. What are your thoughts about that?
Yeah, absolutely. Absolutely we can. And it's a very good question. This technique is called distillation. It's a very popular inference optimization technique. And the main idea is, as you said, Paige, you would take the knowledge from a very large model that might be too expensive to serve, but has very good quality. And then you would distill that knowledge into a smaller model that can retain a good amount of that knowledge and quality of the big model, but is at a size that you can serve. Like I said, it's a technique called distillation. Lots of active research and practice in distillation. There are multiple types that you can distill knowledge from a larger model to a smaller model. One of them is called data distillation, where you use the larger model to generate a lot of synthetic training data for the smaller model, and then you just train the smaller model on that. Another way we can do this is more fine-grained, where we try to align the token distribution for the smaller LLM to be closer to the larger model. And that's what we would call knowledge distillation. And we talk about those types in the white paper that we're publishing with this class as well. And the third type that I would mention is called on-policy distillation, where kind of going back to your discussion with Alexei on RLHF, we would be able to use the same reinforcement learning framework, but in this case, we would use the teacher model, which is the larger model, to effectively score output from the smaller model and use those scores to train and align the smaller model to the larger model. Distillation has multiple types. They're all used in practice based on the use case and based on what we need. And actually, I think in tomorrow's class, one of those cases will be presented as well. I think one of the authors for the Gecko paper, which uses LLMs to produce much better embedding models using LLMs. So you would use the LLM to essentially produce queries for passages, and then you would train the embedding models on that, and you would get a much better performance. I think it was something like 7x better for those embedding models of the same size using distillation. And I think Jin-Hyuk Lee, who's the author on that paper, will be present in the vectors and embedding classes tomorrow.
Very cool. I think what you just discussed will also be very helpful for the folks in our first pop quiz, which should be coming up towards the end of the hour. So I hope everybody was paying attention, all about the great ways that you can use distillation to improve smaller models, and mechanisms to improve models at large. Thank you so much. Yep. And next question. I believe this is for you, Anant. What are some approaches to evaluating large models? You know, we've got these models that have been created, some larger versions, some smaller versions. How do you pick which one that you should use for a given task?
Good question, Paige. And yes, thanks for the community for asking this. And just a heads up, we'll be covering evaluation of large language models in more detail on day 5. We even have somebody from DeepMind who'd be presenting their research on it. So but diving straight into questions. So there's evaluating large language models isn't an easy task because it depends on the task you're evaluating and what you mean by evaluation. There's, of course, classical natural language metrics like Blau, Rouge scores, which you can use. And this is one of the ways you can do it, where you have a reference, like a golden truth, ground truth, when you can see what the LLM generated, and then you can compare the generated response with the human curated ground truth, and you can see to what extent it matches the ground truth response. Now, that is a classical way to do it. However, given the complexity of tasks LLMs are used in, you might not always have such a ground truth. And even when you do, on certain tasks, you can, for example, summarization, there's multiple ways to write a summary, and all of them might be valid, but the ground truth would be just one such instance. So it would not be a valid way to evaluate such cases as well. So what we can also do is use LLM as autorators, where you kind of have an LLM evaluate an LLM, and evaluate how good the response of the generated by the model was. And you can do this in a pointwise fashion, in a pairwise fashion, where you can just say, okay, here's the response, here's my prompt. How well on a score of 1 to 5 does this response score, and why is that the case? Or in a pairwise fashion, you compare two responses and say, okay, tell me for this prompt, which one is the better response? And it says, okay, the left one is better because whatever reasoning. And we actually have that available. So you can use that right away in our Vertex suite through our Vertex AI, generative AI evaluation service. You can try LLM based autorator evaluation, as well as computational metrics like Rouge and Blau, which use a reference point. You can try that out today.
Absolutely. And I've also seen some pretty impressive open source libraries doing auto rating and evaluations as well. Have been really delighted with PromptFoo, which also has the Gemini API support, and some of the other offerings. So great to know that there are Vertex AI options as well as open source libraries to go about doing these evaluations, whether they're human rated or auto evaluated. Very cool. Excellent. Next question from Red365. Can someone please explain why for the first chain of thought prompt, it's also explaining step by step instead of answering that directly? Lee, I see you nodding. Do you want to go ahead and take this question?
Yeah, I can talk a little bit about that, because I had similar examples in the white paper that I wrote. And so first of all, for the folks on the call, like chain of thought of code prompting, and that's a prompting technique where you try to let the LLM generate intermediate steps. And typically you can do that by providing examples on how to reason. And then you don't take the example as what's in the code lab. You try to come up with another example that has similar reasoning techniques. And then you see if it will then showcase the steps. Now, this particular question, and thank you everyone for participating in the collab. I saw some people saying like, hey, because in the question you had to first type in an example where we do not use prompting, and then afterwards we will show an example where we use chain of thought prompting, so you can see the difference. But the problem was that some people already saw the intermediate steps in the first example, while it shouldn't. It's very difficult nowadays with models that get so good. Our models are so good, like we cannot showcase these flaws anymore. But you might be able to reproduce it by either, like, often maybe just resubmitting the question. It might help also just to change the top K, top P, or temperature, so you get more variance in the outputs. And I saw also in the chat some folks saying that switching to the older Gemini models will showcase how you can showcase the flaw, and then later you can fix it with chain of thoughts. So that's cool stuff.
Very cool. I love kind of the detailed description of chain of thought in and of itself, and then also how you can see it expressed as model outputs. This is very, very cool. And personally, I've found, especially for things like coding tasks, chain of thought prompting or asking the model to explain its reasoning has been very, very powerful, and has usually led to significantly better results.
Yeah.
So this is very cool. Yeah. The next question from Woo Sung Hyung is something like enum mode in a fine-tuned model designed to return enum values. And Daniel, it's great to see you, by the way. Welcome back. For folks on the call, Daniel and I used to work together at DeepMind, and now I believe you have started your own company. Or you're still in stealth mode for your company, so I won't give spoilers. But it's great to have you. Would you like to answer this question?
Yeah, sure. Yeah, nice to see you as well, Paige. And yeah, thanks for having me. Yeah, and I think that in terms of enum mode, I mean, it very much depends on what you're trying to do. So if you're fine tuning your model, and you want it to output enums, this depends a lot on how you structure your data. So for example, if you have 3 different enum values that you'd like to output, you would structure your inputs as the question or task that you want to provide to your LLM. And then the output would be one of the enum values, whichever one is most relevant to the question or task that you ask the LLM to provide a output on. So you can fine tune LLMs like that and prepare your data sets with these inputs as being the task or questions and the outputs being the enums. And also, LLMs are also sometimes very good out of the box in dealing with enums. So you can also say to an LLM something like, these are the different types of classifications that you can choose, or enums that you can choose. Choose the appropriate one for the question that we're asking. So suggestion would be to also try it 0 shot, and if not, you can create these fine-tuned data sets. And I think there was a question about related to notebook LLM that was along these lines, Paige.
Oh yes, I believe the question that you were referring to was from G. Srinivas, which is all about Notebook LM, how it was built, how it was created. I've really loved experimenting with it, as well as the Illuminate kind of automatic podcast generator for any arbitrary data types. For Notebook LM, interestingly enough, and this was shared by Josh Woodward at a recent event, it's not using a fine-tuned version of Gemini. It's just using Gemini 1.5 Pro and 1.5 Flash with the addition of some special techniques and some secret sauce, especially around retrieval and around kind of careful prompting and design of the system. So Notebook LM is not relying on a dedicated fine-tuned example of Gemini. It's just using the same Gemini 1.5 models that folks are experimenting with for your assignments. So that's a great way to get inspired. In that, the tools that you're building with are the same tools that folks are using to enrich AI applications at Google, which is very cool. Beautiful.
Just wanted to point out, we noticed there's some freezes sometimes happening from the community on the live stream. And we also got feedback that you'd like us to cover some of the course, like white paper overviews. We'll be covering that later in the call as well. And let us all speak loud so everybody can hear.
Excellent. And with that, I am going to go ahead and thank our presenters again for kind of answering all of the community questions. Make sure to reach out, to connect with them on LinkedIn to learn more about their work or to follow the papers that they've been writing. Virtual round of applause. I know that Riverside does not support emoji reactions, but thank you all so much for your time. This has been really wonderful and a great way to learn more about all of the great content for day one of our generative AI intensive course. So thank you for being here. With that, I'm going to go ahead and move to our next session, which is all about code labs and demos for many of the great code examples that are included in the course. I'm going to stop sharing, and then Anant, I believe you have some notebooks that you want to walk through. Is that correct?
Yes, that is correct.
Yep.
And let me. I believe that everybody on the live stream, I believe the freezing might be happening due to the live chat. So try turning off the live chat. That might help. Cool. Let me share my screen. All right. So hi everyone. Today I'll be going through the collab with you for this session. And before I do that, however, for those of you who are joining the live stream for the first time without going through the podcast or the white paper, let me just take a step back and give you a quick overview of what the first day was about. So you might have received 2 white papers and corresponding notebook LM podcasts. And they talk about basically the first white paper about foundational models walks you through, okay, what are LLMs? How are they, the fundamental component of what makes them? So the transformer architecture, which inspired this whole revolution with LLMs. And then it goes into how do you train LLMs, how like fine-tuning techniques through fine-tuning, as well as reinforcement learning using human feedback and other things. Then we briefly talk about the parameters which are important for LLMs, and prompt engineering, like decoding type parameters, which we'll also be covering shortly in this collab. So things like temperature, top P, top K, etc. The way the LLM constructs the response, and then we talk about prompt engineering briefly, and then we have a whole white paper written by my colleague which was on the call earlier, which talks about prompt engineering techniques, which is the second white paper that you might have received. And then in the first white paper, we then go ahead and talk about how to accelerate inference of LLMs, which my colleague Matched here just talked about through techniques like quantization, distillation, and speculative decoding, as well as others. And then we talk about, okay, now that you've learned how LLMs are built, tuned, trained, accelerated during inference time, as well as how you can utilize them through prompt engineering. Then we talk about few applications in various fields of LLMs, how you can utilize them. So that's a nutshell of what your day one curriculum was about. Of course, this collab here kind of tries to walk you through how you can utilize that. That was the how, and this is the how you can how you can put this to use, and that's what we are going to see right now. So my colleague Mark McDonald was who had created this. He's not here in the call today, but like to give a shout out to him as well. And yeah, let's get started. So on the Discord, we saw a lot of questions around phone verification for internet access. So hope you've gotten that done. That's important, and you've received that in your instructions as well. But feel free to let us know in case you have any more questions. And you might have already seen how to add Kaggle secrets, which is important to the Gemini API. When you get the Gemini API key, you can add that as a Kaggle secret and then programmatically retrieve it in the collab in order to utilize our APIs. This is important. So those of you who haven't started the Colab yet, I hope you've gone ahead and done this. And then in the beginning, part of the Colab, we'll be installing the SDK, the generative AI SDK from AI Studio. And then we'll be retrieving our API key through Kaggle secrets in order to utilize our Gemini API. And then we'll be going ahead and running our first prompt, where we use our Gemini API to just do a single turn prompting, where we just give a prompt in and response out. In this case, I always love it when people can simplify things for me. So explain AI to me like I'm a kid. I love this response. And Gemini, we use our Gemini 1.5 Flash model, which is, as Paige, our host, discussed earlier, that this is one of the fastest models out there. And yeah, and not only can you generate response, you can also format them to make it look nice, right? And then the second part of the Colab, the subsequent part of the Colab, we go beyond single turn interaction, and we kind of see how you can make a conversational interface with Gemini, a chat interface. So you see here that we send a chat message to Gemini telling our name. My name is whatever. And then we ask some, and the model responds. It's a response. And then we send another message asking a completely different question. And later on, we query the model and say, do you remember what my name is? So because in this chat interface of Gemini, it keeps memory, it keeps history internally, it keeps a record of what was discussed earlier and what his response was. So it remembers the name correctly. And so this is how you can utilize in conversational applications, utilize Gemini in conversational applications, and can be very useful while implementing LLMs in production. Moving on. So since LLM, the world of LLMs is moving quite fast, and there'll be we have a lot of models coming out, and you can also you might have also trained your own models or tuned your own models. So this is how this section talks about how you can kind of list the models that you have at your disposal, and you can see how you can list them, the various kinds of models, and you can also get more information about a certain particular model. For instance, we use the Gemini 1.5 Flash, the 001 version, the first version of Gemini 1.5 Flash. It has an input token limit, the context window of 1 million, output of around 8,000, and the default values you can see here as well for generating a response. Now, talking about generating a response, for those of you who haven't read the white paper yet, just let me give you a high-level overview. So LLMs work by generating tokens at each, step by step. So given the input prompt, it will look at the input prompt and generate the next most likely token. And each of those tokens are selected from all the possible tokens it could generate that it was trained on, but each one of them have an associated probability score given the past sequence which was generated. So, the system works by sampling, by saying, okay, looking at the probability scores of each token at each step and choosing a token based on those probability scores. So the generation step, there's a lot you can do to influence the output response. And that's what we're going to briefly be looking at here today. But please look into the white paper and the podcast for more details of how it works. One parameter is...
Yep. Anant, would it be possible to zoom in a little bit? On the code. This is great. I love seeing kind of the ways that you can interact with the models, and then also kind of inspect and see which models are available to use. I also frequently like to do if I'm not sure which version of Flash or version of Pro is the latest, you can do Gemini-1.5-Flash-latest, and it ends up grabbing just the most recent version. So this
exactly.
Yep. Thank you for
yeah. Yep. Zooming in literally as well as conceptually. Thanks for that. And yes, thanks, Paige, for pointing that out. And yeah, so once you've figured out which model you'd like to use, there's a lot you can do at generation time. One of the parameters is output length. You can kind of cap how big or how large your output, the number of tokens that's generated by the response of, or are present in the response of the LLM. And just something to keep in mind is you can cap it. You can say, okay, I will only want 200 tokens. I only want my response to be 200 tokens maximum. It could be lesser. But it does not stylistically change, it does not stylistically force the LLM to fit its response meaningfully within that restraint. So that what that means, maybe it's more obvious with an example. Let's say you ask the LLM to make a 1,000-word essay. Those of you who played with the Colab, you might have seen this example. You asked it a 1,000-word essay, and that's much more than 200 tokens. So it's not going to magically compress the essay into 200 tokens. So you can see here, it stops mid-sentence. And that's the thing. So it can reduce, and it can reduce the cost, because you're billed at, if you use a paid version, you're billed by the amount of tokens you generate as well, one of the factors, and you can reduce the cost, and you can kind of force your LM to limit the output length, but you cannot it doesn't make the response meaningful always. So you have to keep that in mind. And you might want to do some prompt engineering and change the prompt if you want to actually generate meaningful short responses. So like write a short poem, and this would fit within 200 tokens for sure. Now moving on, we discussed earlier how LLM generates its response by sampling probabilistically at each step by step the tokens based on how likely the token is at how likely all the tokens are at each step. Now, one of the things that can influence the probability and change the quality of the response, not just the length, is temperature. Think of temperature as a way to influence the probabilities, and lower temperature means the token with the most so tokens with higher probabilities get even higher probabilities of being selected, and the lower ones get even lower. And a higher temperature means more or less all of the gap between the best tokens and the worst tokens is narrowed. So basically, what that means is a lower temperature ensures that, or increases the probability that you will get kind of similar output even if you run the LLM repeatedly. And a higher temperature gives a bit more diversity or creativity and randomness to the output. Let's look at that with an example. Let's say we prompt the LLM to pick a random color. We ask the random color and answer in a single word. But as you see here, with a higher temperature value of 2.0, the colors are different. We looped through it 3 times, and the colors are multiple times, and the colors are different each time. But if we have temperature fixed at 0, then the color is purple every time. So it's the same. So the variability is reduced when you keep the temperature low. Talking about temperature, that was on influencing the probabilities. But what about across all tokens, right? But what about selecting limiting the amount of tokens we select from, not just modifying the probabilities, but limiting and filtering kind of the top well-performing tokens and then selecting from within them. That's exactly what top K and top P does. And they kind of, top K and top P, in the interest of time, I won't go into detail, but they basically limit the kind of the search space at each step from which the tokens are selected. You can use top K and top P parameters in conjunction with temperature. And this is something you can play around with to see if it matches what you would like to see. Now, briefly covering prompting, the various prompt techniques, which you also see in the second half of the code lab, and we have sent a white paper around prompt engineering as well. So if you'd like to dive deep, go have a look at the white paper, or at least listen to the podcast. One of the most basic techniques is how people know prompting is zero shot, where you basically give a LLM an instruction, say you want it to classify movie reviews into 3 buckets, positive, neutral, and negative. You give the review and you ask for the sentiment. Notice here, you're just giving it an instruction and you're giving your input, but you're not giving it more directions or examples or even explain what positive, neutral, and negative means for you. And it will work in some cases, but in other cases, it might not. That's good to keep in mind. And also remember that you're asking the LLM to generate positive, neutral, or negative as a free text field, but you might want to restrict that to like make sure that the output that comes out is definitely one of positive, neutral, and negative, and you don't have to, it doesn't generate anything else in addition to that. So this is where you can use our enum mode, where you can, especially in problems which are very well structured, such as classification problems, where you want the output to be restricted to a certain format or certain set of words. This can be very useful, where we use the same example, but this time we have limited the output space to exactly positive, neutral, and negative. You see here that here it was positive with stars around it. And here you do not have that. You have it what we told it to output. Now, we talked about earlier around giving an instruction and just asking the LLM to generate an answer. But we can go beyond that. We can give an example or even multiple examples of input and output to the LLM, and it helps it understand by example. And that helps improve performance in certain use cases. You would see an example here. And then you see here that giving a few examples of what the response should look like helps it reason and generate better responses. Now we can control the structure to a more granular extent of LLMs, and this is what you see in this part of the Colab in JSON mode, where you can ask the LLM to output well-formed JSON structure, and this can be very useful, especially when used for coding and programmatical purposes, when you want a well-formed data structure in a downstream task. And there was a question on chain of thought, moving on to more prompt engineering techniques like that. So chain of thought, as my colleague answered earlier, is a technique which instead of just asking an LLM to give you an answer, it basically elicites a reasoning process. You ask the LLM to reason about it and maybe even give examples about the reasoning steps. And that helps improve performance on certain tasks which benefit from this reasoning intermediary steps. For example, here we are talking about when I was 4 years old, my partner was 3 times my age. Now I'm 20. How old is my partner? And we asked the LLM to return the answer immediately. Now, you see here, it gives you the incorrect answer because we asked it to give the answer immediately while the model could have benefited from the reasoning steps, intermediate reasoning steps. So that's where now we try and ask the model to think step by step, and it managed to come up with the correct answer, and it does so by explaining. It kind of does a calculation and uses that logic intermediate reasoning steps to arrive at the answer. You can go beyond this. You can even give it examples. So few short chain of thought where you kind of give it examples and then write the reasoning of how the output was arrived at, and it can make it even more powerful for certain tasks. Talking about reasoning, we have another powerful technique which was discussed in the white paper, and we see that here, reason and act. So developed by Google. So React framework is one where you can we don't just ask the LLM with a single response to give us an answer. We have the LLM is a multi-step workflow where the LLM does searching. It thinks about, we have it interleave thought, action, and observation steps. So we give it a prompt, we ask it to think about it, and then take an action, maybe call some tools and tools like maybe even APIs and SDKs, which will be going into more detail in the agents day 3 session. And then see the response it got from, say, a database, reason about the response, then take a further action, and so on and so forth. This is a very powerful technique which can, when implemented properly, can be very powerful in applications which require multi-step workflows. And going on to our last section. So here we saw how you can use LLMs from also text generation LLMs like Gemini for generating code. So we see here that it can be used for generate code directly, but you can also see that you can use it you can have the LLM not only write code, but also execute code by using some of our tools. For example, code execution tool where it figures out, okay, to answer a certain prompt, you might need to do some calculations or execute some code, and it can do so. It can write that code and execute it behind the scenes and give you the response as well.
And I just want to being mindful of time. It looks like we are at time, and it also sounds like there have been some AV issues with folks on the live stream. So just want to say thank you everybody to attending. We will make sure to post. We will make sure to post a video without any of the live stream kind of technical difficulties on YouTube, so folks can watch and can see. And we'll also be sharing the pop quiz immediately afterwards. Thank you so much, everybody, for dialing in, and to all of our great questions and answerers. Thank you, Anant, for presenting the notebooks. We look forward to seeing you tomorrow. I really appreciate you. Really appreciate your time. Thank you, and see you tomorrow.
Thank you.
Bye. All right, everyone. Now it's time to put what you've learned to the test. We're going to have our first pop quiz for day 1, all about foundational models and prompt engineering. So get out your pens, your pencils, your paper, or just something to quickly jot down your answers. The next 6 questions will test your learning comprehension, both for the white papers that were part of the homework reading, as well as everything that you've heard in the Q&A today and our code labs. So with that, I'm going to go ahead and get started with this first question. Which Gemini configuration setting controls the degree of randomness in the selection of the next predicted token? We discussed this a little bit in the code lab, but hopefully you are paying attention. So I'm going to give you a couple of seconds to think about your answer, and to show the multiple choice options. We have temperature, which is value A, top K, which is value B, top P, which is value C, and output token count, which is value D. Which one of these, which Gemini configuration setting controls the degree of randomness in the selection of the next predicted token? Hopefully you're getting your final answer. And I am going to count down to show the answer in 5, 4, 3, 2, 1. Hopefully y'all all picked temperature, and temperature is that sort of knob that you can dial that controls the randomness in the selection of the next predicted token for your model. Beautiful. I hope you got it right. And if not, make sure to go back and refer to the reading as well as the code labs to help build that knowledge base. So question number 2. Which of the following is not a technique used to accelerate inference in large language models? Some options that we have quantization for value A, distillation for value B, flash attention for value C, and fine-tuning for value D. This was covered a little bit in some of the Q&A, as well as the white paper readings. Which of the following is not a technique used to accelerate inference in large language models? And I'm going to count down 5, 4, 3, 2, 1. And hopefully everybody picked fine-tuning. Fine-tuning is not a technique used to accelerate inference in large language models. Next question. Which of the following is a unique characteristic of the Gemini family of large language models? Something that Gemini possesses that other large language models do not. We're going to show the answers. So number 1, Gemini models were the first to introduce the concept of unsupervised pre-training. Value B, Gemini models can support multimodal inputs. Value C, Gemini models are decoder only. Or value D, Gemini models can support a context window of up to 2 million tokens. Which of the following is a unique characteristic of the Gemini model family? I'm going to start counting down. Remember, this is something that Gemini can do that other models cannot. Counting down 5, 4, 3, 2, 1. Hopefully everybody picked D. Gemini does have a 2 million token context window for Gemini 1.5 Pro, which is significantly longer than other models available today on the market. So if you missed this, make sure to go back and refer to our white papers as well as to experiment with the Gemini models in AI Studio. Question number 4, how does reinforcement learning from human feedback improve large language models? And remember that section of the Q&A with our great guest speakers from the Gemini app. So value A, by training the model on a massive data set of unlabeled text. Value B, by using a reward model to incentivize the generation of human preferred responses. Value C, by reducing the number of parameters in the model for faster inference. Or value D, by converting the model into a recurrent neural network or an RNN for improved performance. How does RLHF improve large language models? And so think about what your answer will be. Remember also the white papers and the great Q&A conversation that we had a little bit earlier. 5, 4, 3, 2, 1. Hopefully everybody picked B, which is reinforcement learning with human feedback uses a reward model to incentivize the generation of human preferred responses. So as you're getting feedback from your users, all of that is going back into the model to help improve it over time. Question number 5, we're almost to the end. Which technique enhances an LLM's reasoning abilities by prompting it to produce intermediate reasoning steps, leading to more accurate answers? This you should remember from your code lab as well as from the reading. So value A, zero-shot prompting. Value B, step-back prompting. Value C, self-consistent prompting. Or value D, chain-of-thought prompting. Which one enhances an LLM's reasoning abilities by producing intermediate reasoning steps? I'm going to count down 5, 4, 3, 2, 1. D, chain of thought prompting. And hopefully everybody will go back and experiment with this. I found it to be really, really useful for, especially for kind of complex tasks or things that will require the model to write code. Chain of thought prompting usually helps quite a bit for this. And final question, and I will say this is a tough one. You'll have to have been reading very, very carefully the white papers and all of your homework assignments. What is the minimum GPU memory needed for inference on a 3 billion parameter model using standard float precision? Is it value A, 3 gigabytes, value B, 6 gigabytes, value C, 12 gigabytes, or value D, 24 gigabytes? And this is related to your reading. I will say that if you have hardware targets that are a little bit different, some of these values might also be a little bit different. And it might depend on how you've int quantized your model. So if it's int 4 versus int 8. But I'm going to start counting down. 5, 4, 3, 2, 1. C, 12 gigabytes. If you got this right, I am extremely impressed. This was easy to miss and is also something that is really, really increasingly important as we're starting to get smaller models available for inference. So with that, thank you so much for attending today, for learning, for the great questions that you've been asking on Discord. We're excited to see you come back tomorrow. And make sure that you tally up your answers for the pop quizzes so you can see how you've been improving over time. Really hope you enjoyed learning more about foundational models and prompt engineering. And tomorrow we will see you back bright and early for vector databases and embeddings. Till next time, and thank you again.